Hey y'all, welcome to our 22nd and final lecture for Math 1319. We're going to be doing chapter 6.4, inverse matrices, and we're going to jump right in. Identity and inverse matrices. Recall that the identity element under multiplication of real numbers is 1, since for any real number a times 1 is a, 1 times a is a. There exists an identity matrix I sub n for matrix multiplication, and it is the n by n square matrix with 1s along the main diagonal and 0s for all other elements. Then for an n by n square matrix, we have that a times I sub n equals a and I sub n times a equals a. For example, I sub 2 is going to equal the 2 by 2 identity matrix. I sub 3 would equal the 3 by 3 identity matrix. I sub 4 would equal a 4 by 4 identity matrix. So now let's show we have A equals 1, 2, 3, 4. Let's do AI. So that means we're going to have row 1, column 1. So row 1, column 1. That's going to be 1 times 1, which is 1, and 2 times 0 is 0. Next, let's do row 1, column 2. So we'll have 1 times 0 is 0, and 2 times 1 is 2. Next, we'll do row 2, column 1. So that's going to be 3 times 1, which is 3, plus 4 times 0, so just the 3. And then lastly, row 2, column 2, just going to be 3 times 0 is 0, 4 times 1 is 4. So we got our original matrix A back. Now let's test it going the other way. So let's do now I times A and make sure we're getting the A matrix back. This would technically be I sub 2. Sorry, I forgot that subscript the first time. I sub 2, because it's a 2 by 2 matrix. So now we're going to do row 1 times column 1. So again, we get 1 times 1 is 1. And then we will do row 1 times column 2. So we'll get 1 times 2, which is 2. And then we will do row 2 with column 1. So 0 times 1 is 0, 1 times 3 is 3. And finally, we will do row 2 with column 2. So we get 0 times 2 is 0, 1 times 4 is 4. So you can see that the identity, or A multiplied by the identity, is equal to the identity multiplied by A is equal to A. Not too bad, right? So let A be an n by n matrix, and let I sub n be the identity of the matrix of order n. Then there exists an n by n matrix A inverse, such that A multiplied by A inverse is equal to the identity, and A inverse multiplied by A is also the identity. And an example of this would be if we had A equals 4, 3, 13, 10, and B, well, I'll call it A inverse, and A inverse is equal to 10, negative 3, negative 13, and 4. All right, so we need to test it both ways. So let's try first, we'll do A inverse. So first thing we'll do is row 1, column 1. So we're going to have 4 times 10 minus 13 times 3. And then that's going to be equal to 40 minus 39, which is 1. And then row 1, column 2 is going to be 4 times negative 3 plus 3 times 4, which is negative 12 plus 12, which is 0. And then row 2, column 1 is going to be 13 times 10 minus 13 times 10, which is going to be 0. And then finally, we will have row 2, column 2. So it's going to be 13 times negative 3 plus 10 times 4, which is negative 39 plus 40, which is 1. So we get the identity matrix. So that checks out. So now let's do A inverse times A and make sure we get the identity matrix. So first we will start with row 1, column 1 per usual. So we'll have row 1, column 1. So it's going to be 10 times 4 minus 3 times 13, which is 1, because that was the same as the previous example. And then we will do row 1, column 2, which is 3 times 10 minus 3 times 10, which is 0. And then we will do row 2, column 1. And we'll get negative 13 times 4 plus 4 times 13, which is 0. And finally, we will do row 2, column 2, which is negative 13 times 3 plus 4 times 10, which is 1. So they check out. So these two matrices are in fact inverses of each other. So now we want to determine whether A and B are inverses. So first what we'll do is A times B. So A times B is going to equal, well, row 1, column 1. So we'll have 3 times 5 minus 2 times 7, which is 1, because that's going to be 15 minus 14, right? And then we'll do row 1, column 2. So we get 3 times negative 2 plus 3 times 2, which is going to be negative 6 plus 6, so 0. And then we'll do row 2, column 1. So it's going to be 5 times 7 minus 5 times 7, which is 0. And finally, we want to do row 2, column 2. So that's going to be 7 times negative 2 plus 3 times 5, which is negative 14 plus 15, which is 1. So it works out this way. We got the identity matrix. However, now I need to try B times A. So B times A is going to be row 1 times column 1. So we get 5 times 3 minus 2 times 7, which is 1. And then we want to do row 1, column 2. So that's going to be 5 times 2 minus 5 times 2 is 0. And then we want to do row 2, column 1. So we get negative 7 times 3 plus 7 times 3, which is 0. And finally, we want to do row 2, column 2. So we're going to get negative 7 times 2 plus 5 times 3. Negative 14 plus 15 is 1. So it works out. So yes, right? Awesome. Let's keep moving on. So finding the inverse of a 2 by 2 matrix is actually rather nice. We have a formula for it. We label each element A, B, C, and D, and then A inverse is going to equal 1 over AD minus BC times, and then you kind of rearrange the letters. So you get D, negative B, negative C, A. So what I'm going to do first is just label all of the elements. So this is A, B, C, D. So we'll have A equals 2, B equals 9, C equals 1, and D equals 5. And then what I'll do is, so that means A inverse is equal to 1 over, and we want AD minus BC. So AD is going to be 2 times 5 minus BC, which is 9 times 1. And then we're going to multiply that scalar by, and now we want the matrix to be in order D, which is 5, and then negative B, so 9, that's negative 9, negative C, so that's a negative 1, and then A, so that's 2. Essentially, you switch these two and then make the top right and bottom left negative. So this is going to equal 1 over, that's 10 minus 9 times 5, negative 9, negative 1, 2. And this is just equal to 1 times 5, negative 9, negative 1, 2, or 1 over 1, if you'd rather write it like that. Either way, A inverse is equal to 5, negative 9, negative 1, 2. Pretty nice, right? Let's keep going. Finding the inverse of a 3 by 3 matrix is much more complicated, and we don't have a really nice trick for it. We just kind of have to go for it. So essentially what you're going to do is augment the matrix with the identity matrix. So it's going to be step 1. So we're going to have 3, 0, 2, 2, 0, negative 2, 0, 1, 1, augmented with our 3 by 3 identity matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. Now your goal is to make the left side be in reduced row echelon form. So the first thing that you are going to want to do is make the very top left row 1 column 1 equal to 1. So I'm going to do negative row 2 plus row 1 gives me the new row 1. So that means I will have, so 3 minus 2 is 1, and then those are zeros. Then that's going to be 2 plus 2 because it's negative row 2, so I'll get 4, augmented with 1, and then negative row 2, so here in this side, don't forget to think about this side, that's going to be negative 1 plus 0, which is negative 1, and then 0. All right? And then the other rows did not change, so I still have 2, 0, negative 2, 0, 1, 0, 0, 1, 1, 0, 0, 1. So next I want to make this point as 0, so I'll do negative 2 row 1 plus row 2 gives me the new row 2. So that's going to be, well, row 1's not going to change. All right, so the new row 2, so I'll have negative 2 plus 2, which is 0, and then 0. And then negative 2 times 4 is negative 8, minus 2 is negative 10. Negative 2 times 1 is negative 2. And then that would be 2 plus 1 is 3, and then another 0. And then my last line did not change. All right, so what I want to do next is going to be to switch row 2 with row 3. Since I have this really nice 1 here, I actually want that to be in the second row. So that means I'm going to have, so let's see, we'll have 1, 0, 4, augmented with 1, negative 1, 0, and then 0, 1, 1, negative 2, 3, 0, and then 0, 0, negative 10. Oops. I'm sorry, I'm wrong. So you have 0, 1, 1, 0, 0, 1, so I'm switching that whole row 3, and then negative 2, 3, 0 on the bottom. All right, now this is going to be where it's going to get a little odd because we have to have a 1 here. So we're actually going to multiply by negative 1/10 times row 3, and that's going to give me my new row 3. So I'm going to get 1, 0, 4, 0, 1, 1, 0, 0, 1. And then on 1, negative 1, 0, 0, 0, 1. And I'll have negative 2/10, 3/10, 0. It may be easier, just since we're adding and subtracting matrices, to write this as negative 0.2 and 0.3, just so we don't have to deal with fractions for the moment. All right, now I'm going to use my row 3 to cancel out the numbers in the third column on rows 1 and 2. So I'm just going to do negative row 3 plus row 2 gives me my new row 2. And then it's going to be negative 4 row 3 plus row 1 is going to give me my new row 1. So that means I will have, so row 3 is not changing, so I'm just going to copy down row 3. And negative 0.2, 0.3, and 0. Okay, so negative row 3 plus row 2, so it's just going to be 0, 1, 0. But now I'll have, instead of negative 0.2, I'll just have 0.2 plus 0 is just 0.2. And then negative 0.3 plus 0 is negative 0.3. And then 0 plus 1 is 1. All right. And on the top row, I'm going to have negative 4 row 3 plus row 1. So I'll have 1, 0, 0 on the top row. And then negative 4 times negative 0.02 is going to be negative 0.8. I'm sorry, positive 0.8 because it's a negative times a negative. And then we're adding that 1, so we get 1.8. And then we'll have negative 4 times 0.3, which is going to be negative 1.2. Negative 1.2 minus 1 is going to be negative 2.2. And then in the last column, we just have zeros. So now we have everything that we need. And you can write them back as fractions now. So instead of having like 1.8, you would have A inverse is equal to, so 18 over 10, negative 22 over 10, 0, 2 over 10, negative 3/10, 1, negative 2/10, 3/10, 0. Sorry, let me fix these matrix brackets. And then from here, you can just simplify all of your fractions. So 18 over 10 is the same thing as 9 over 5. And then negative 22 over 10 is going to be negative 11 over 5. And then you have that 0. And then 2/10 is a fifth. And then negative 3/10 just stays. And then 1. And then negative a fifth, 3/10, and 0. And that is it. So basically, once you've completely reduced your matrix and you have it in reducer echelon, whatever is on the right side of this augment is going to be your A inverse. And that's how you find the inverse of a 3 by 3 matrix. It's a much longer process, but we have completed it. Okay, let's keep moving on. So the last thing we need to talk about is going to be singularity. So not all matrices have an inverse, and if the matrix does not have an inverse, we say that the matrix is singular. And a matrix that does not have a multiplicative inverse is said to be invertible or non-singular. So an invertible matrix is a matrix that has an inverse. So the last example we did, this one, A would be considered an invertible matrix because an inverse for it exists. However, there do exist matrices that do not have an inverse. So let's take a look at this one for starters. So the first thing we're going to do is augment it with the identity matrix. All right, and now we want to get the left side into reduced row echelon form, and then the right side will give us our A inverse. So the first thing that we can do is -4 times row 1 plus row 2, since we already have that 1 in the top left corner. And so that will give us, I'm sorry, this gives us our new row 2. And so that will give us, well, the top row is not changing, so we have 1, 2, 0 augmented with 1, 0, 0. And the second row is changing, so we'll have 0, and then we'll have, let's see, -4, so it's -8 plus 5 is -3. Then 0 plus 1 is still 1. Then -4 times 1 is -4, and then a 1, and then a 0. And then the third row didn't change, so we have 2, 1, 1, 0, 0, 1. All right, next we want to get this 2 out of the way. So we can do -2 row 1 plus row 3 is going to give me my new row 3. So that means my row 1 and my row 2 are still not, or row 1 is still not changing, and then row 2 is not changing this round. Row 3 is going to change because we'll have -2 plus 2 is 0. -4 plus 1 is -3. 0 plus 1 is 1. -2 plus 0 is -2, and then 0, and then 1. All right, well, now we can cancel out row 3 with row 2. So we can do row 3 minus row 2 is the new row 3, since they're the same. So then that will give me, we'll have 1, 2, 0 still, and 1, 0, 0. And then 0, -3, 1, -4, 1, 0. All right, so that means 3 minus 3 is 0, 1 minus 1 is 0. And then I'll have row 3 minus row 2, so it's -2 plus 4, which is going to be +2. 0 minus 1 is -1, and 1 minus 0 is 1. All right, have you now noticed the problem? Oh no, we have all zeros. This is not good. This means that the left side, so this was the kind of the matrix A, but the left side cannot be changed into the identity matrix. So that's going to be I3 in this case. Or you can think of it as put in like the RE, right? Because our reduced row echelon form for this matrix would actually be with all the zeros in the third row, since we can't make it into a 1 on that third turning point. So since we can't change it, we would say this A is a singular matrix, i.e. it has no inverse. And that's it. It is singular. This concludes the lecture, our final lecture for the course. So I'd like to thank you all so much for tuning in to our entire math course. And I hope that you have a wonderful rest of your summer.